In the previous part, we wrote this map for our console game. Now let's add some units on this map and write some movement logic for them. The first function is addEnemies with no parameters. This function always generates the same unit on the first row of our map. However, the enemies index will be chosen randomly. Let's start from the enemies index. I wrote enemy index equal to math.random. Eventually, we want to have the input from 0 to 4 inclusive. This function returns the number from 0 to 1, where the 0 is inclusive and the 1 is exclusive. So the actual range of this function is from 0 to 0.999. To extend the range of this function, I can multiply this function by 5. And if I want to calculate the result, I need to take both edge numbers. So the edge numbers for this function are 0 and 1. And then I need to multiply them by 5. 0 multiplied by 5 is 0 and 1 multiplied by 5 is 5. So the range that we will have is from 0 to 5. But the last number of this function is exclusive, so the actual range from 0 to 4.9999. We also want to have only integers, so math.random function gives any number from 0 to 1. But we want to have only whole numbers, only integers between 0 to 4. For that, I can round this function with math.floor. This function rounds the number down to the nearest integer. And to remember this function, the word floor can be associated with down. This function gives the range from 0 to 4.999, and if we take this last number and round it down to the nearest integer, eventually we will have integers from 0 to 4 inclusive. So I can write that this function returns any integer from 0 to 4. Then let's take the first row from our map and put the enemy on this row. Map array is a 2D array, and to access the first row of this array, I can use 0 as the index. But the row is an array that contains tiles, and I can access a specific tile using enemy index. I set the tile that we accessed by enemy index to E that represents our enemy. Actually, you can choose any letter that you like, but I choose E. Let's write a similar function for allies. I found that I named our previous function addEnemies, but actually we add only one enemy, so I will rename it to addEnemy. The structure of this function is the same. The first line, as we had in our addEnemy function, we need to get the index. This time we don't get the index randomly, we get it from the user. For now, let's assume that the user gives a valid index so we can skip validation. Of course, in the future, we should add validation, but now for the simplicity, let's assume that the output is valid. I want to show how prompt function works, so I will call this function in our while loop after the draw map. And now you see that we have this map in the console, but we also have a pop-up message where we can type something. So for example, I can type 0 and then press OK. And in this case, my prompt will be equal to 0. All this function will be replaced by 0, but this 0 will be a string. But in our case, there is no difference that the response is a string, because JavaScript is smart enough to convert strings to numbers in the case when we use a string as a number. For example, in our previous function, if I try to access the tile with index 0, that is a string, JavaScript can automatically convert it to a number with a value of 0. A lot of other languages can do it, but JavaScript can. This is the reason why we don't need to convert our prompt to integer. In our addEnemy function, we accessed the first row because this is the first row and we want to put our unit on a tile on this row. If we're talking about allies, we want to access the last row and to put our enemy on a tile on this line. In this case, I access the row by index 4 because totally we have 5 rows and we remember that indexes are 0 based, so it means that the 5th row index is 4. And now let's set addAlly on a tile. And finally, we accessed the tile by ally index and set it to capital A letter that represents our ally. Let's think about movement logic for our units. Enemies should move down and allies should move up. Let's have a look on enemies. The logic that I suggest is to check the next tile. If the next tile is empty, we can remove our enemy from the current tile and then we can set it to the next tile. But if on the next tile is someone, we need to determine if this is an ally or an enemy. If this is an ally, we have a battle and we can just remove both units. But if on the next tile is an enemy, we have a problem. We can't put 2 units on one tile. So how to solve this problem? The solution that I found is to process units starting from the last row and moving to the first row. So for example, we have this situation where 2 units are close to each other. We can check the last row. If on this row is any enemy, we should move him down. We see that this row is clear. Then we go to the next row and we see that here is an enemy. So we should move him down and eventually this row is clear. We go to the next row. Here we also find an enemy and we want to move him down. But now we know that on this row can't be enemies because we moved them down. So it means that we can move our enemy down, or if we have a collision, we definitely know that both these units are on different sides. So we can just remove them. Now we have a plan for our function. So let's write it in our code. The name for our function is moveEnemies. This function will move every enemy that is on the map. This is the reason why enemies are plural. Then we want to iterate through each tile, but we need to start from the last one. For that, I write a for loop with a starting index of 4. During this loop, we can get each row. So let's save it in a variable. And now to iterate through each tile, you have 2 choices. You can iterate from last to first or from first to last elements. At this point, it doesn't matter. Both solutions are valid. You can choose whatever you like, but for the consistency, I would choose a for loop from last to first element. So let's save this tile in a variable. I want to move only enemies. So let's check if tile equals to E. In this case, I know that the current tile contains an enemy and I should move him down. At first, I should check if there is any collision with the next tile. Let's write a new function enemy collision to handle the logic of collisions. But we will complete this function later. Of course, we could write the logic of collisions inside of the moveEnemies function, but this is a good practice to give only one responsibility for each function. In this case, it will be easier in the future to understand what this function does, and it will be easier to debug it. When we call moveEnemies function, we only want to move enemies. We don't want to have any side effects. In our case, this function also should remove enemies if they collide, and for that, we write enemy collision function to handle this logic. We don't need to fill this function right now. All what we need is to assume that this function returns one of the 3 values: true, false, or undefined. It returns true if there is a collision, and it returns false if there is no collision. Also, it can return undefined. Undefined means that our unit should go out of this map, and in this case, we want to declare a winner. Let's process each output. If the collision is undefined, we want to declare a winner. But again, I want to write a separate function for that, because declaring a winner is another responsibility. Let's create a function setWinner, and we will provide a winner to this function. I write this function, but we also complete it later. Also, in the parameter winner, I use underscore that represents a private variable. Essentially, I put it because we already have a winner in the global scope. And in order to keep the same name, I just put an underscore. Again, we just assume that this function stops the game and declares a winner. And if we call this function, we can also add a return keyword. The return keyword also stops the function when executed. It means that on the point when this function reaches this keyword, it is finished. And we want to finish our moveEnemies function because we already know the winner. So there are no sense to continue our game. Now let's handle the second case, where the collision is equals to true. We also have a shorthand for this if statement, which is just collision without equals to true. So this statement implies that it is equal to true. Now we know that only enemies from different sides can collide to each other. So it means that if we have a collision, we want to remove both units. So I want to set the current tile to a hash. You might think that the variable tile contains the current tile, and this is true, but we can't change our map through this tile. We have the variable raw. This variable is an array. When I access the element in this raw, I actually have the string, so this hash symbol. And tile has a separate cell in the memory where he cloned this symbol. So it means that tile and this hash symbol have nothing in common with our raw. So this is just a clone of one element from our raw. It means that if we change this data, it will not influence our raw. And this is the reason why this tile doesn't change the global map. If I want to change the global map, I actually should add this raw with index of j instead of the tile, and then I should change this element to a new symbol. When I change an element in this way, I actually go inside of the raw with index of j, and then I change this specific index. It also doesn't change or doesn't influence our tile. So it means that even though that I changed this raw to a hash symbol, our tile is still an enemy. So when we create a new variable tile, we put a checkpoint where we clone the data from our array. And then I can change this data, but my tile will not be changed. This is as a checkpoint. I also want to cover one interesting note that is beyond of this video. If you try to store a full array into a new variable, in my case I store raw in a variable raw2, it will not copy and paste this array to a new variable, it will just create a pointer to the same array. All what it means is that raw and raw2 are actually the same variable, and if you change one, it would change the another because it is not a copy, it is just a pointer. I also can represent it in this way where raw2 is equal to raw and is equal to an array. So it doesn't make a new copy, it just creates a pointer, this equal sign to the same array. We won't use it, this is just for your knowledge that you can't copy arrays in this way. So let's return back to our function. So as I said, if we have a collision here, we need to change the current tile to a hash map, and then we also need to change the next tile to the hash map. For that, let's take the next raw. I maximize this window to write this function. If we access the current raw with the index of I, we can access the next raw with the index of I plus 1. J is an index for column, so we are on the same column, so we can just use J without any changes. And now let's write our final condition where the collision is equals to false. In this case, we don't have any collision, so we want to remove the enemy from the current tile and set it to the next tile. I set the current tile to a hash symbol. Then I access the next raw. And now I set the next raw with the index of j to e. I know that this was a difficult part, but with experience you will understand it better and it will get easier. In the next video we will implement the ally movement and finish the collision functions.